S is a geometric sequence. Given that the following are the first three terms of S, find the value of x. We know a geometric sequence is connected by what we call a common ratio, and we know we call the common ratio the letter R. Hence, if I divide two consecutive terms, i.e. my second term divided by my first term, here we're going to have 1 divided by root x minus 1. That's going to equal to my third term divided by my second term, in this case root x plus 1 divided by 1. As I'm asked to find the value of x, if we have a fraction equal to a fraction, we can cross multiply. Hence, top left multiplied by bottom right. Well, 1 times 1 will give us 1. Multiply my opposite diagonal, so bottom left times top right. As I have two terms, I'm going to end up with double brackets. So I've got root x plus 1, multiply in brackets root x, subtract 1. Leaving the 1 on the left-hand side alone. Expanding my double brackets on the right. I know that root x multiplied by root x is simply x. I know root x multiplied by negative 1 will give us negative root x. I know positive 1 multiplied by root x will give us plus root x. I know positive 1 multiplied by negative 1 will give us negative 1. Leaving the left-hand side alone, I've got 1. Simplifying the right-hand side, i.e. collecting like terms. Here I've got x, I've got no other term ending in x, so leave that alone. Here I've got negative root x plus root x, they'll cancel, and I've still got negative 1. As I want to get x by itself, I now need to move the negative 1 from the right-hand side across to the left. If you move a term over an equal sign, it changes sign. Hence, the opposite of minus 1 is to add 1 to both sides. On the left-hand side, 1 add 1 gives us 2. On the right-hand side, I'm just left with x. As I know negative 1 add 1 will cancel. Hence, x equals 2. Show that the fifth term of s is 7 plus 5 root 2. Now I have my value of x. I can now determine my original geometric sequence. Hence, my first term would be root 2 minus 1. My second term is simply 1. And my third term, in this case, would be root 2 plus 1. To find my common ratio, which we call the letter R, all I've got to do is to divide two consecutive terms of my geometric sequence. In this case, the easiest would to divide the third term by the second term. So to find R, I'm going to divide my third term, which in this case is root 2 plus 1. Divide by my second term, in this case, 1. Well, dividing by 1 has no impact, so my common ratio in this case is root 2 plus 1. As the third term was root 2 plus 1, to find the fourth term, I'm going to do the third term, in this case, root 2 plus 1, multiplied by my common ratio, which I just worked out to be root 2 plus 1. As just two terms, always place that inside single brackets. As I've got two terms times two terms, I've got double brackets. Expanding out my double brackets, I know root 2 multiplied by root 2 is just simply 2. I know root 2 multiplied by positive 1 will just give us plus root 2. I know positive 1 multiplied by root 2 will just give us plus root 2. And 1 times 1 will simply just give us 1. Simplifying, i.e. collecting like terms, I know 2 add 1 will simplify to give us 3. And I've got root 2 plus another root 2. They're like terms as they both end in root 2. If there's no number outside the root, the number's 1. So 1 lot of root 2 plus another 1 lot of root 2 will give us 2 root 2. I now know the fourth term is 3 plus 2 root 2. As I want to find the fifth term, therefore I do the fourth term, in this case, 3 plus 2 root 2. Again, multiply by my common ratio, R, which I know in this case is root 2 plus 1. Again, I've got double brackets. Expanding out my double brackets, well, 3 multiplied by root 2 will give us 3 root 2. I know 3 multiplied by positive 1 will give us plus 3. 2 root 2 multiplied by root 2 will give us plus 4, because we know 2 root 2 multiplied by root 2. Laws of thirds. If the number's outside times the number outside, if there's no number outside, number 1, give us 2. And we know a root multiplied by itself just gives a number. So root 2 times root 2 is simply 2. And 2 times 2 gives us the 4. And finally, 2 root 2 multiplied by positive 1 will give us plus 2 root 2. Simplifying, i.e. collecting like terms, I have 3 plus 4, which gives us 7. I have 3 root 2 plus 2 root 2. They're like terms as they both end in root 2. So 3 lots add 2 lots will give us 5 lots of root 2. Hence, we've showed the fifth term of s is 7 plus 5 root 2.